Hello, friends and enemies. Just kidding. We're all friends here, aren't we? Hey, we got a little bit of combo platter today. We are going to look at combining Chapter 7, Sections 8 and 9 into one kind of truncated, abbreviated version. So if you take a look at your note sheet here for Chapter 7, Section 8, we are going to start with example 5 down here. We are going to focus on the multiplying binomials. The four-letter F word today is what we're going to be focused on, not the four-letter F word you're thinking of, fart. We're thinking of another four-letter F word today called FOIL. And in algebra, what FOIL stands for is my acronym for multiplying two binomials together. And a binomial, again, is just an expression that has two terms. So like x plus 2 is a binomial because there's two terms. And x minus 5 is a binomial, another two terms. So I'm taking two terms times two terms. So in a sense, I am using the distributive property two times. Distributive property twice. And here's what I mean by that. If I'm going to multiply x plus 2 times x minus 5, for instance, I need to first multiply the first term, x, to both terms in the second binomial. So what x times x can be thought of as is I'm multiplying f, the first terms, together. So x times x is x squared. Next, I'm going to multiply the x and the negative 5 together. And if you think about location, the x and the negative 5 are the two terms that are furthest to the outside. So O in FOIL is I'm going to multiply my outside or outer terms together. X times negative 5 is negative 5x. Then, so there's my first distributive property. Now I'm going to use the distributive property again. 2 times x, the 2 and the x, well, if x and negative 5 are on the outside, the 2 and the x are on the inside. So 2 times x is 2x. And then if x and x are the first, 2 and 5 are going to be the last. So 2 times negative 5 is negative 10. With FOIL, almost all the time you're going to have middle terms that are like. So you're going to want to put those together. Again, any term that has the same variable and exponent, as we saw in section 7, can be combined through addition and or subtraction. So my final result is going to be x squared. That's the only x to the second power. But the negative 5x and 2x will combine the negative 3x. And then I have minus 10 as my numerical value. So there's my simplified expression. Again, first, outside, inside, last. Put your like terms together, clean it up. Let's take a look at another example. So I'm going to FOIL, since I have a binomial times a binomial. So I've got first, a times a squared. O on FOIL is outside. A times 4 is 4a. Inside, 3 times a is 3a. And then last, 3 times 4 is 12. Check your middle terms. 4a and 3a will give you a total of 7a. And then plus 12. So a squared plus 7a plus 12 is your final result. We're going to take a look at some special cases here, examples 7 and 8 from the 7-8 notes, and then we will solidify that with the 7-9 notes. So example 7, here's one little, I don't know what you want to call it, a little tidbit or a necessary operation or format, if you will, when you are taking a binomial squared. Remember, to square something means to multiply it by itself. So if I ever have a binomial like x plus 5, and I want to square it, that means I need to multiply x plus 5 times itself. So I need to write it out 2 times. So x plus 5 times x plus 5. So what I have then is a binomial times itself. And I'll continue with that FOIL pattern. X times x, I'll get x squared. X times 5 is a 5x. Inside 5 times x is another 5x. And then last 5 times 5, 25. I'll put those middle x's to the first power together. 5 and 5 gives me 10x. So I've got the x squared plus 10x plus 25. And then we'll take a look at a subtraction example, x minus 3 squared. Again, if you have a binomial and you square it, you need to write it out twice. X minus 3 times itself, x minus 3. I'll then go f first, x times x, x squared. O outside, x times negative 3x. I inside, another negative 3 times x, or a negative 3x. And then be careful here on your last. You have a negative 3 times a negative 3. Negative times negative is a positive 9. So your final result will be x squared, negative 3 minus 3, minus 6x, plus 9. And then 7, 9, that's all we're going to cover for the 7, 8 notes, those 4 examples. 7, 9 just really illustrates the special cases of squaring a binomial, which we just talked about in example 7. Again, if I'm going to square a binomial here, example 1 on the 7, 9 notes, just to reiterate the importance of x plus 4 squared means multiply x plus 4 times itself. So I've got first outside, inside, last, x times x, x squared. Outside, x times 4, 4x. Inside is another 4 times x. And finally, last, 4 times 4 is a sweet 16. My like terms, 4x and 4x, will give me 8x. So x squared plus 8x plus 16. Isn't this fun? Oh, that's a 3-letter F word compared to FOIL, our 4-letter F word of the day. Type 2, just to reiterate, I don't need to go through all examples. I think you can hopefully follow that. So we'll just go from example 1 on the 7, 9 notes to example 3. This follows example 8 from the 7, 8 notes. Again, if I'm going to square something, multiply it by itself, write it out twice. 6a minus 1 times 6a minus 1. First, outside, inside, last. 6a times 6a is 36, and then a times a squared. 6a times negative 1 is negative 6a. Another negative 1 times 6a is a negative 6a. And then be careful on these, as we said, negative times negative is a positive 1. Negative 6a minus 6a is negative 12a, and then plus 1. All right, our last special type here with example 5. This is when I have identical terms, AA BB, 7, 7, NN. The only difference here is one has addition between the first two terms and one has subtraction between the second two terms. All right, so here's what happens in this case. So I'm going to go 7 times 7, 49. 7 times negative n is negative 7n. Then I have positive n times 7 is positive 7n. And then n times negative n is negative n squared. So in this case, if you look at your two like terms in the middle, negative 7 plus 7, well, if I have 7 n's and take 7 away, I've got none. So what happens is the middle two terms cancel out, make 0. And all I'm left with is 49 minus n squared. So that is the last special case you will see. Again, the only reason is that it's special is because the middle two terms make 0. It's still the same first outside, inside, last process. So that's what you're doing today. Get that 4-letter F word FOIL and multiply those binomials out. Enjoy!